Okay. So I'll just continue from where I left off, which was, I believe, here. So yeah, these differences and the normal for loops. I'll just comment this out for now from here. So I will start with a whole new part for the while loop. Alright, so while loops, they generally work very similar to for loops. The difference is that you don't have this initialization and the increment inside of the condition. So like, in general, how I would specify it, like how I would like split them, is that for loops are for doing it a certain number of times, and the while loops are for checking conditions of certain like sorts. That's very simple, but for now we're just doing simple programs, so that's why I'll put it as that. Later on, it's gonna get way more complicated, so you'll understand that later on when you start making those kind of programs. But for now, that's pretty much it. This int kind of idea is still there, so I'll put this to 2. So this int, by the way, I'm starting this off similar to this. So like I'm just trying to show the similarity between while loops and for loops. And then while number is less than 4, and I will put just simple print thingy. Okay. Number. By the way, for loop, something I forgot to mention is that you can use I inside of your actual like for loop. You don't have to use outside variables, and that's somewhat beneficial. I guess people probably did that for like lab 4 and lab 5. Just that's something to also keep in mind. That I don't think you can do in while loops because you don't have like a condition here similar to this condition. So yeah, that's just something to keep in mind if they test on that. You can use like conditions inside. It's not illegal. Or sorry, not conditions, variables inside of it. So let me just print this for now. And the main thing is you don't want to do that. So I realized what I did wrong. Alright. You don't want to create an infinite loop. That is wrong.
You have to reset your studios when it does that?
Yeah. For Genie, you have to, I mean, if you guys use Genie, you just have to close the thing, but for VS Code, because it's integrated. So yeah, I know where I did wrong. It's that I didn't increase the number. So it's always 2, therefore it's always less than 4, and that's why it's always going to print the number out. So that's actually good, by the way, in my opinion, creating infinite loops, sometimes by accident, sometimes on purpose, to understand how the loop works. So if you have time like before CPS midterm, if you want to understand loops better, just mess up like that. It's not going to destroy your computer, hopefully. And yeah, let me just fix that now. And what I'll do is I'll put a ++ here, which will increase 2 by 1 every time this goes through. And I shouldn't get an infinite loop this time. There we go. So I print, so these are actually, this is not 23, this is 2 and then 3, but like I'll just prove that with 7, and it should give me, yeah, there we go. So the while loop works similar to the for loop for this kind of case. For something like, generally you don't have to do this kind of condition in here, because sometimes you have like let's say this. If you put a scanf inside of your loop, or inside of a while loop specifically, and then you change the number, wait, that wouldn't work. You have to put this here. Alright, so you change the number each time you kind of do the loop, and what you want to check for is this specific condition. You want to make sure it's less than 7. I'll remove this just to show that the scanf does fix that. So let's say you want to loop to check if it's less than 7 all the time. So let's start with something that will be less than 7. It's going to output that number. So 4, 5, 6, 7. Now it outputted 7, but then the program stopped because the while loop stopped pretty much. So that's something to keep in mind, because what happened in the while loop was that you scan the number and then you print the number. So even though I entered 7, which is greater than, or I guess it's equal to 7, it still printed it because this was in the print, like in the while loop. Let's say if I change the order of these, which is likely going to happen on the midterm. They just change order of stuff and whatnot, very boring things. So let's say I do the same exact thing again. 4, 5, 6, 7. Doesn't print it this time. Why? Because this condition checked before this print statement went. In the other scenario, the print statement went before the condition was checked. So very small difference, but very major result difference, basically. So that's something that while loops do. Like, that's pretty simple. I don't want to get into really complicated stuff, but that's the idea of how they work. And I'll probably do a file IO later that uses the while loop kind of idea. So yeah, that's just pretty much while loops and a very simple thing. If anyone's got a question on that, let me know. Or if you want me to make like a more complicated program. But yeah, that's pretty much it for while loops. I was gonna do switch. I don't know if I should make like a big switch case, because we did a switch case, I believe, in lab 4. I don't know. I'll leave it for now because I already have a nested loop here, and I don't want to do that until I finish this. So I will leave that for now. I might do it later, but switch. We need to know switch, by the way. Not that I'm just skipping it because we don't need it. Like, we don't need to know that for the midterm, but it's just like, it's pretty easy to learn by yourself. It's like pretty much a multiple if statement. If I get to later, I'll explain it, but okay, for now I'll do nested loops. And nested loops can be while loops inside of for loops inside of while loops, for loops inside of for loops, etc. You get the idea. What happens in a nested loop is generally very hard to kind of decode yourself, I guess, if that's like kind of the right wording, because nested loops, they have a lot of outputs going on at the same time in like a matter of milliseconds, and it's kind of hard to see every single number happening at the same time. So for now, I'll just print this, which I made before. I'll just print this. Oh, what? Why is that giving me an error? Oh, because I made this n. Okay, let me make this. Where did I define n? Oh, here. Okay, let me just delete that. Alrighty, so I'll just rerun that. Okay, why is it only giving me 2? Hello? Am I looking this wrong? Okay, might have crashed, I'm not sure. Let me just make sure I did this right. Okay, that's interesting. I ran it before and it worked. Let me just reset VS Code. I don't know why it's doing that. Alrighty. Oh, I think I know why I'm an idiot. Because I put the scanf. That's why. Amazing. Alright, now it should work. There you go. That's the dumb problems that people face. Alright, perfect. So now it outputted exactly what I wanted. Let me explain what's happening here. So to start off, you declare a number called n, and that's just equal to 5. And then you make a while loop statement. And that statement is basically just creating this condition that while it's less than 9, do whatever is inside of the while loop. And this will keep outputting until 5 is 9 itself. Or I guess it could be greater than 9. It depends on what you put inside of it. But generally, if it's 9 or greater, that's when this will stop. So what is going on in here is that this keeps going every single time, and then you have another for loop inside. So I created 3 different printfs to show the difference between them, and you can see the actual things here. So you can see how many times the for loop went, how many times the while loop went, so inside the while loop, and then how many times the outside the while loop went. And so what happens inside the program is that while loop only goes, so you can see from here, this while loop only goes once. Even though it seems like the program would just, do it multiple times, it only goes once, and that's because of the for loop inside of it. And the for loop inside of it, now because we did this before, I'll just skim through it. This is initializing I, this is creating a condition for I, and then I minus minus is the same thing as I equals I minus 1. Same idea as the plus, just different, sign right here. So that's what it's doing, and then every single time it does this loop, it increases I by 1. So this n plus plus, or sorry, it increases n by 1. So this variable right here. And then it prints n, and then it does the whole for loop again. So it comes back up here, does this, adds 1, and comes back. So it's going to keep doing this until 3 becomes negative 3, because we're decreasing by 1 every time. And so this would go, like if you were doing this on the midterm, you would have to do this logically, or like kind of analytically speaking. That's why I'll do it right now just quickly, which is basically this is what happens. You have I is equal to 3, so it goes 1 time. And that means n becomes 6. It's going to print 6, which is here, right? And then it comes back. It decreases I by 1, so this becomes 2. And then this condition is still true, so it adds 1. This becomes 7. It prints out 7, which is here. And the same thing keeps going, so you can continue using that same method. This becomes 1, this becomes 0, becomes negative 1, negative 2, and then becomes negative 3. So in total, you can see how many times it went just using this, but in general, you would have to do it yourself. And it's the same idea for all the nested for loops / while loops, because you can't really do something insane unless you put like 4 to 5 loops inside of it, and that would become really, really hard to decode. So they won't do something like that. They'll mostly do something like this, or they will do something like a multiplication table that they showed us, which was they put another for loop here and another for loop here, which goes a certain amount of times, and you're gonna have a number of different answers outputting all the time. But for now, just to keep it simple, you can see it output 1, 2, 3, 4, 5, 6 times, and then it output it inside the while loop 1 time. So the while loop only went once. Why? Because by the end of this kind of sequence, you're going to have 11 as n, as many times as this for loop goes, and you're going to have 11 here, and you're going to come back to this condition, but 11 is greater than 9, so this condition is false, so it comes here. Now for example, if I change this to be 1, for example, let's just say that. So it would go 3, and then it would subtract 1, so it becomes 2, and it becomes 1. So technically speaking, this should only go twice, and you're going to have a print here, and then it's going to be still less than 9, whatever number it ends up to, and then it'll go again. So I'll just run this to show that. Hello? Oh, is it because I highlighted it? I think it's because, okay, there we go. So now this gives you a completely different output just by changing one number. So here the for loop goes twice, the first time, and then the while loop ends. But then because 7 is still less than 9, it's going to go again. So the for loop goes twice, then you're going to get 9 at the end. And since 9 is less than 9, or sorry, greater than, or equal to, I keep saying greater than, it's going to make this condition false, and then it's going to print this at the end. So you can see like the differences between these print statements. And this is like something I think they tested us on a bit, at least for Miriam. She tested us a bit with like quiz questions and stuff. So that's why I'm just saying like these are pretty tedious to do, and you might want to do them on paper just to like know which ones, like do it a couple times on your own, like make your own program and do it a couple times, and then you can check your output by actually running the code and seeing what you get at the end. But yeah, this is like a pretty I guess big combination of stuff, because you're printing stuff, you're doing a for loop, you're doing a while loop, you're initializing stuff. So a lot of stuff's happening in here, and you want to understand everything going on so that you don't mess up. Because like, it could say, for example, if it gives you this exact program right here, it could say what prints out at the end, what prints out in the third printf statement, right? And then you would know this is 9 by running the code, but you wouldn't know it's 9 until you actually go through this for loop, and you do the for loop once. This is going to end up to be 7, so this is going to be less than 9. This goes again, and you get the idea. So I guess the big takeaway from this kind of code, because I don't want to do another for loop inside of a for loop, is just very annoying. So the big takeaway here is to just understand like what's going on inside the loops, because a lot of the time you can run into just missing one number, and that messes up the whole rest of the loop. Like, let's say for example, if I did this on paper and then I didn't realize this for loop goes twice at the beginning, and I set it just equals 6 at the end, and then this would change a lot, because then you say, okay, it's equal to 6, 6 is less than 9, this goes twice, and then it's equal to 8, so 8 is still less than 9, and then it goes on, and you messed up like the entire thing, and then you would have a completely different answer. And most likely they would have that answer in the multiple choice, or they're just going to say none of the above. You're going to choose that and mess up. So yeah, you might want to do a couple of these programs, and maybe just a couple of normal loops if you're not familiar with nested loops. But yeah, I don't want to spend too much time on loops. So like, a lot of it is just trial and error, honestly. So doing it yourself is probably best practice. Even though I'm teaching through a code editor, it's not going to teach you as good as you making the code and then testing it yourself and then doing it on paper and whatnot. So yeah, I guess that's pretty much it for loops and kind of if statements. If statements, you could also put an if statement in here, honestly, and then that would become another whole kind of code thingy that you would have to deal with. So you can add stuff into your own programs, I would say, and test stuff out, see what works. But I would say that the biggest code they would probably give us is a nested loop with only 2 loops. I don't think there would be 3 loops, because that would be insanely hard, unless it's like if it only goes twice here and then it only goes twice here. That wouldn't be too bad, but I wouldn't expect like something insane. So I would say just understand how the loops work, and you're good with that. So now I want to go to file IO functions. I'll come back to switch case later on, but I want to do file IO. I'm not sure if they'll do file IO on the actual exam, but I want to do this because a lot of people had problems with lab 5, and you kind of want to know what's going on in file IO for later on. So this is just a quick thing I made, which was basically before explaining all this stuff here, basically it takes stuff from this file right here, which is just a bunch of numbers, and it prints the numbers out in 2 different ways. So I will just comment this loop out for now because it's more complicated. This is not totally on the midterm. Like, I'm not 100% sure if this is going to be on the midterm, but I just want to show this because it is kind of important, and I don't know how many people here know file IO that well in C. So anyway, yeah, you can see the output here, and I'll explain what's going on here. So this requires pretty good knowledge of loops, because you start manipulating loops to the point that like you have to know what the while loop is doing, and that's what's going to help the rest of your code here. So that's why I'm saying like these simple things, like all these basics, if you don't know them right now, or if you didn't like understand it fully from me explaining it, you might want to create your own code or like search it up on YouTube videos and whatnot. And yeah, that's like the best solution to have for just like that, specifically just loops. But okay, so first off, to call a file, you make a file and then you make a pointer. I haven't gone over pointers much because it's kind of hard to explain in a code editor. Like, it's pretty useless the way they teach it to us. So I would say the best thing to do is just look at like the lecture, like the slides from the study hall, because I think they did explain it there. I also have a recording, so if anyone wants to DM me for the recording, just let me know, because Pulse 60, very fun. You can't put it in here apparently in the server. So yeah, this is a pointer. Pretty sure everyone should know at least what that is. If you don't understand the concept, it's fine. But this is just pointing to this specific variable. So this statement is equal to if I did this basically. Let me finish that and sample file. These two statements are equal, and I won't get an error. So this was just kind of shorten it, but if you want to understand how the pointer works, it just points to this variable, and then I open the file. So this is the file name. Make sure the file is in the actual folder that you're using, or like with the C file, otherwise it won't work. So that's why you can just put it like this. R is for read, W would be for write. You can search those up, there's like a bunch of them. And then these are just a bunch of variables. Now this is where file IO kind of starts off, and these two statements are kind of the basis for file IO, but there's other stuff which is more complicated. I don't want to explain here, but this is kind of the basis. This means file end of file, so EOF, and this is just end of file. And I might explain this one after if I don't take too long, but this just means while you're not at the end of the file. Oh crap, I forgot to explain not. Okay, hopefully everyone knows what exclamation mark not means, but if you don't, just unmute and I'll explain it properly. But it's just saying that while you're not at the end of the file, like this condition is just saying while you're not at the end of the file, do what's inside of the loop. And fscanf is used for scanning from files. Printf would be for printing into a file. That's pretty much the basics of it. I don't think we need to know too much more than that for CPS, but yeah, you can search that up on your own if you want to. So yeah, fscanf, fprintf. I think there was something called fputs or something like that, or just puts. I don't know if they use that in the actual midterm, but I would just read up on some file IO just in case, but I don't think there's too much file IO on the midterm. I'm just going over this for kind of coding purposes, in general coding purposes. Now this would be normal printf, this would be normal printf, and now I can show you what the loop actually does. So you can see here there's two numbers, and there's another two numbers, and then there's another two numbers. So what this code does is it takes the first number and it puts it in N0, and then it takes the second number and it puts it in N1. And that's why I put like 3 different rows of these specific like separations. So this goes to N0, this goes to N1, and then it prints each one like respectively, and then it starts the whole loop again. And since this is not the end of the file, because if you go here, you can actually like see what a computer's doing. If you just select this and you continue going, and then you go to the next line, you can see there's kind of a space here, but it also goes to the next line. So that's what I'm trying to talk about, where you're not at the end of the file. That's how FEOF works. But you are at the end of the file when you go here, because you can't select more. So I'll explain that, or yeah, that's pretty much explained with this while loop. And then you can see that here, because 18 goes to N0, that's printed. This goes to N1, this goes to N0, this goes to N1, and yeah, that's pretty much file IO in like as fast as I could do that. If someone didn't understand it, let me know, because I did that pretty fast just to get over with it. But we didn't do too much file IO in class, and I don't know if you guys did, but I don't think they're going to test on it, because it's kind of hard to test without the actual text file available, and that would be a lot of code to do in 4 minutes. So yeah,
Yo,
yeah, go ahead.
I'm guessing the questions they'll ask is more on like the notation, as in like would this print like a file? You know what I mean?
Yeah, exactly. So a lot of the stuff that I said in the previous recording, which messed up, I have to go re-record that. So a lot of the stuff that I said was that at the beginning, I mentioned that most of the stuff is going to be notation. So you have to know this, but you also have to know that if you took this out right here, that's going to mess this up a lot. And most likely this is going to become false and nothing's going to work. So you have to know like what each part of it is doing. You can't just say, oh yeah, you know what, I know this part because Isa explained it, and then I know this is just scanning it. No, you have to know that this is scanning it, what this is doing. This is calling this file right here which you opened. This is %d because it's an integer. This is taking it and putting it in the address of this variable. and then this is kind of printing the original variable. So like you have to know all these working parts basically, and if I take out like, for example, if I take this out right here, that's going to give me an error in the actual thing, and I can't actually run this program, or I could probably do it, but it's still going to give me an error. So you have to know like what can cause errors and what, like if I take that out, that's still going to give me an error. So like, I don't know who said that, but whoever said that, like that's kind of what they're going to test on, because they can't test on a specific program since they're not actually letting us code. You just have to know all of these and what's going to give you a logic error and what's not. I think that's pretty much it for this like section of code. Does everyone understand this, by the way? Like if you have a question, just let me know, because I did it pretty fast, but it's not too hard to understand, I hope.
Yo, one question.
Mm-hmm.
What does the FEOF stand for?
Okay, so this stands for, here, let me put it here so I don't have to. Here. This stands for file end of file. Basically just asking for the end of the file, basically. This, if you go further into coding, this has a value and it has sort of kind of own thing, but I just put in the simple way because we're not going to use it too much in the course, I believe. Maybe we use it later on, like for lab 9 or something, but I don't know if we use it that much for this course. So just
Right.
yeah, that's pretty much it. And then this stands for EOF, which is just end of file. So I'll put that here before I explain that part of the code. So now I just want to prove something interesting to you guys, which is that you don't have to do stuff one way in coding, and you can end up with the same output using two different, somewhat different types of code. So I will print this out, and you get the exact same code, like no difference in the code, like at all. And the reason is because what I did here was I moved all of these like scanfs into the condition, and then I changed the condition to not equal file. Like this is basically saying this right here, but in one statement, which is that it's not the end of the file. And you scan it inside of the condition. So you do your scans, these scans, inside of the condition here, and then you say, while that's not equal to the end of the file, print out these ones respectively. And there's an interesting thing here, which I don't think it'll change the program, but let me just check it, which is that you have to know the notation. So yeah, it doesn't change the program, but it does help with the notation of kind of like here, if I move this text file over here, you can see that there's a space between these. So the computer doesn't really care about the spaces, but it kind of helps for seeing it yourself, because you know that these spaces help with like knowing this is this column and that's this column basically, and then you know which one is printing to which, instead of just like clumping everything up. Like this would be very applicable if you have something like this, like if you have 5 of those and then you put like 5 numbers here. So like if you put that, then it kind of helps you see what's going where. That makes sense. So yeah, just keep that in mind. That's pretty much the same exact loop. I won't go over it again, but all I did was I clumped these up into the actual condition, and yeah, I made it more kind of efficient, which is pretty much coding in a nutshell. You're making stuff efficient. Once you learn it the first time, you just want to make it more efficient the next time. So yeah, that was pretty much file IO. Like just a quick overview, because I don't think they're going to test too much on it. Like the guy said, it's probably going to be notation based if they do test it. I don't think they're going to actually give you like a text file and tell you to, you know, say what exactly the output's going to be. That was more lab 5 stuff. But yeah, that was that. I'll leave that to the side for now. Let me close lab 6. Alright, now the last thing I believe is functions. That should be the last thing we're being tested on. I don't know if, let me think. I don't think we're going to be tested on like, what do you call it, multi-results or something like that, where you have like multiple returns from one function. So this is pretty much the simplest, or I guess this would be the last thing kind of, if you put another in here. But yeah, I'm not going to do that because it's kind of overcomplicated. But you could, I guess you could technically have that. So just keep that in mind. where you have two kind of int statements or doubles or something inside of this. I might add it on later once I explain the functions, but this was like the other major concept, the last one that we had. So I'll do this, and I might go back and do switch statements if people are down. But yeah, let me just make sure OBS is recording this. Alright, so let me start off here, which is declaring the functions in the first place. And I did two different ways of this, just so people know like how functions work. If you make a function after int main, like here, you have to declare it at the top in order for it to work. So what it does is, like, as a computer, if you're speaking in computer, you take this, you take this, and you move it all the way to the top. Even though you declare it at the bottom, you move it all the way to the top, and then you can use it inside of int main. But if you don't put this here, I don't even know if it'll give me an error in VS Code. It might give me an error after, but okay. Let me see. Let me just actually, before I say that, let me confirm that this doesn't work. Yeah, there we go. So it won't work because you need to declare function 2 before int main, because you put it after int main, and this is two different functions. So int main itself is a function that we've been using like for half this course, but you can make your own functions outside of int main and then use them inside int main. Int main is basically like the kind of, I guess, the grandfather of functions, if you want to think of it that way. But yeah, that you have to declare them at the top if you use them at the bottom. Generally, I would say just use them at the top, honestly, and then you don't have to worry about this kind of notation thingy. But yeah, if you do use them at the bottom, keep this in mind. So what these functions are doing is basically, you have this like name of the function. You have the name of the function, which is here, and then you have the parameter inside of the function. This is not applicable for void functions, but I'll get to that after. I haven't made one yet. I'll just make one after. But this is basically putting a variable inside of it and doing something with the variable. So you're returning something related to the variable, basically. And in this case, I'm just dividing this, and in this case, I'm just multiplying it by 2. And based on that, I'm kind of creating two functions where you multiply and then divide. So let me actually run the program so it's not confusing as to what I'm doing here. So I enter a number 8. 8 divided by 2 is 4. 8 multiplied by 2 is 16. And what I'm doing here is basically I declare 3 variables. Oh yeah, something you don't want to do, by the way, so you don't like mess up the variables in case. You want to put A, B, and C out here. I'm pretty sure the program will still work as normal, but you don't want to do this. The main reason being because you're using A, B, and C only in this. If you're using A, B, and C in this function and in int main, then yeah, it's a good idea. But otherwise, it's like, it's better just not to, because you're creating more room for error. But yeah, this basically you declare them here, and then I create a printf for like a kind of command, and then here you're scanning it. So we went over this stuff before. Then here, okay, so what I did to simplify this, because technically speaking you could put this in here, right here, but I just simplified it by putting in two different variables. So function 1 is taking A and it's putting A in here, and then it's dividing A by 2, and then it's returning A divided by 2, and then it's putting that in B. That's what the computer's saying in like milliseconds, but logically speaking that's how it works, right? And it does the exact same thing with C. So what you do is you take function 2, which is this, you put A in here, A multiplied by 2, you return A multiplied by 2, and you put it in C, and then you print C out, and that's what's here. So this is B, this is C. This would also work, just to prove it, if I took this, put it in here, took this, and put it in here. And let me run that. 8 again. What in the world? 8. And it works fine. So you can do it both ways. I just split into like variables so that you understand, in case they use like variables like this, what's going on in the variable. But you can do it both ways. and it's not an error, by the way, so keep that in mind. But yeah, that's like the simplest way of functions. There's also, I believe, void functions, which is like the other thing that we learned, which was basically void function 3, and you don't put anything in here, and then let's see, I can just do like 2 times 2, I believe. That should work, I think. I haven't done too much void stuff. It's not, like, in my opinion, it's not that useful, but let me just see. Ooh. Oh yeah, I'm supposed to, okay, so yeah, by the way, you should declare this at the top. So that's good that I got that error, just to show it. So you have to declare this at the top, and then I want to print want to print void, so function 3 is %d. I'm not 100% sure if this will work, by the way, so don't, like, just kind of test running it here. Yeah, that's not gonna work. Okay, so I kind of forgot how void functions work, I'm gonna be honest, so I might have to go redo that. But there's also void function, just to go over that quickly, which basically you don't return anything. So I don't think I even need this, actually. So you don't return anything in a void function, you just have like something in it, and then you call that up inside. Oh, I know why. Okay, my bad. So function 3, you're just supposed to call it up, you're not supposed to print it or anything, and you can do the print in here. So let me try it here, and comma, then oop, why didn't that happen? Okay, so let me see if that works. Alright. Oh crap, why did that happen? Is it because of the thing? Okay, let me put this after, just so that it's not confusing. Let me run that now, and it's afterwards, whatever. Okay, let me put a slash in here. This is basically coding, like, this is what's gonna happen all the time. Run into these small things. Alright, perfect. So now, this is a pretty simple example, but just because I don't want to go into too much detail for these. Void, you don't have this return thing. You don't want to put it at all. You just have something inside the void function, and then you can simply call the function in here. So instead of, like, obviously here it seems pretty dumb because you can just put this in here, and then why do you need the function? But let's say, for example, if you had like a bunch of code, like you had 3 to 4 lines in here, and you wanted to constantly do that, instead of copy pasting those 3 to 4 lines like multiple times, you can just call up this function multiple times, and you'll be fine, and it will print that, like, or do whatever you want it to do. So that's something to keep in mind, which is void functions can be used, or I'm pretty sure they're going to be used in the midterm along with these kind of int, or like return functions, I guess, if you want to call them that. These might have multiple variables, so just keep that in mind. I haven't done it here, but they could have multiple variables, and then you have to use, like, let's say if I added another int d, and then I did something with d, which was, why is that not working? Oh, that's why. So you could have that, and I'm not going to do like the actual thing here, but okay, actually before I do that, you can see that there's a kind of squiggly line, which is that there's an error with the function too, which is because you added another variable here. So you want to add like c into here, let's say. Now that would work. I'm not actually going to print it because I didn't do anything with d, but like that's the main idea, which is basically you use 2 different variables in the same function, and then you can do like I don't want to make this too complicated, but like t is equal to num plus d, and then return t. You can do something like that. I don't know if I'll actually run the code properly. Oh, yeah, I don't want to do that. Let me change this. Oh, this is actually a good example, so let me actually run that. Scan a, let me copy paste this. So as you can see, by the way, D is used twice in this, but it's not going to change the value of D, like mess it up in the program. So let's change these. So let me run this. Alright, so this is going to go to A, and then this is going to go to D. And so now something interesting happened, which is basically this. Function 2 went, function 1 went, which is just dividing by 2. So I divided 3 by 2, which gave me 1 because it's integer division, which rounds down. And then D, which is basically this function here. And this function is adding the first number and the second number. And A, as we put it, was 3. D, as we put it, was 5. So 5 plus 3 is 8, and then that becomes, so I still have multiplied by 2, but ignore that. This is 8, which is the addition of this function. So there could be two kind of variables in here. They might not just use one, they might use two. So that's something else to keep in mind. And I think that's pretty much like a wrap for functions. They could get more or less complicated. Yeah, go ahead.
For functions, like making the function and doing like variable plus another variable, how is that more efficient than just doing than just printing like A plus B, if that's possible?
It's not.
It's not?
Yeah, it's not. But the whole
Oh, shit.
yeah, the thing is, okay, I don't know if you heard it before, like how long you've been here, but the thing that I said is these programs are pretty retarded. Like these they're not gonna you're not gonna use these. These are really dumb. Like you could just put these in here and then like print it out as many times as you want. But what the use of this is if you make like a program, let's say if you made a function calculator in here, you don't want to put that entire calculator in here if you're going to use it like 3 times, let's say.
Oh yeah.
So you want to put that calculator in here, and then you can use function 2 3 times, and it's just going to give you one line of it. That's pretty much what like the use of it is. So like in general, I'm going to be honest, CPS is pretty dumb for teaching the really basic stuff in a really complicated way. But the use of it is if you make way more complicated stuff, you have to know how these work in a basic way so you can do it in a more complex way. But yeah, as you said, like this, you could just literally put this in here and then print that. So I'm making like pretty, basic programs, but you can make it more complicated if you want to learn functions more. I don't know if we'll have like complicated functions because I'm pretty sure most of us just learned it in class, so I don't think they'll give really, really complicated ones. But yeah, just you might want to learn this if you haven't already. This is just a basic overview of like how this is different from this and different from void. They're all 3 different types of functions, and you can use them all in different, like multiple different ways, like a lot of different ways. So that's basically it for functions. Before I go on, anyone else have a question? Or if you don't have to say no, but if you have a question, just speak up. Alright.
Wait, did you say the functions can be called either before or after the main?
No. You mean like this?
No, like defining the function.
Yeah, you can define it here. So I could have defined void up here. So I could have used this up here. Like I could literally.
Alright, so what matters is just not in the main function. That's the only like rule.
Oh yeah. That's something important. Yeah, you don't want to put it in the main function because
anywhere else is fine.
Yeah, anywhere else is fine.
Alright, cool.
But if you define it after, that's something to keep in mind. You have to define the actual function before as well. So like you just have to define it. You don't have to. You just put a semicolon after you finish. But you have to define it above. If you put it under main, if you put it before main, you could just leave it like this and that's fine. And it will give you the same result. So yeah, don't put it in main. That's something important. Yeah. So if there's any other questions, let me know. I think that's a wrap on functions, file IO. I did this before, so if anyone missed it, I'm going to re-record it because the recording seriously messed up. But if you missed it, this was just the simple stuff I went over, kind of printf, scanf, expressions, if statement, loop, for loop, while loop, nested loop. I have it on switch case, so it's kind of 10:10. I don't want to keep people. All right, are you guys fine going a bit longer? Because if you want to learn, like, if you want to do switch case review, if not, I can just end it there. So.
It's fine.
All right, then I'll try and do this in like 10 minutes. It's probably not going to be a really big part of the midterm, but I would just say you have to kind of know it in case they do make a question. So how switch case works is, I think we did this in lab 4, so I'm going to use the same idea, which is that you start with a kind of, let's just say I start with, okay, let me just, okay, you know what, screw this. Let me make a new program in, alright, and, oh yeah, something I forgot to talk about is you always want to have this thingy. I'm pretty sure everyone knows that by now because you wouldn't have made a single program without it, but you want to have include studio at the top. By the way, something like if I put here, if I put hashtag include math, so math.h is its own function, but it's a predefined kind of function library, which is a bit more complicated, but basically it does this stuff with a bunch of other things. So like for example, if I write m_pi, pi is defined in m.math or math.h. What am I saying? So math.h, this is defined in that. That's like basically a function. So this is something to keep in mind, that these are actual functions, but they have like their own predefined stuff in C. And yeah, that's pretty much that. I forgot to mention for functions, but okay, so back to switch case. How switch case works, let me copy my if statement. So I believe that was it. So this was, oh, I have to define n. So int n is equal to 2. Or actually I don't want to equal it to 2. I'll just leave it as n. So yeah, this is n plus 2. Or plus 1, I guess. This should just print out 1 because n is automatically defaulted to 0. But what this does, so if you missed the beginning part, why is it doing this? Oh, I didn't copy this part. Okay, so if you missed the beginning part, I explained what this if statement does, but I'll just review it quickly. Basically, I start with this declaration of n. I prompt the user for a number, and then if it's less than 0, which is a negative number, it checks for negative numbers, basically, this program. If it's less than 0, then it's going to output this right here, which is just 1 because this is automatically set to 0. And then if it's a positive number, which is just else, which is every other case, it's just going to print out the number you gave. So I can run that just to show it. 5, it prints out 5. Negative 1, it'll print out 0. Okay, actually even better. So it'll just print out 0. So that is, wait, let me just make sure I'm doing this correctly. Negative 1. Oh, okay, my bad. Let me just make this 1, honestly. It'll make it simpler. I want to explain why I'm getting weird numbers. Alright, there we go. So because it's negative, it prints out 1. That's here. So that's basically how the if statement works. Now switch statements, they work a bit differently, which is basically, okay, so there we go. VS Code gave it to me. So what you start off with is something called switch, and that's its own kind of expression. Now let me comment this out for now. So its own kind of expression in here. It's not a actual like condition where you had for like loops, where as an example like here you had n is less than 9. That's not what you have here. Here you just have one expression. So you can have like literally an expression just n. That could be your entire expression, and that would be valid. So It's not going to be a condition, but it doesn't have to be like really complicated either. So you can just have something like that. Now, how the case part works is you specify so there's two different ways. So for case, for integers or doubles, I guess, you would have numbers. Or actually, I don't think doubles would work. I could try it after, but for integers, you have numbers like this. And then let's just add more cases. So case for, and then you want to code something in here. So let's just, okay, let me put a bunch of printfs in here. Just bear with me for a second. Comma 3. Actually, I want to put it in here. And then copy and put a break after it. So something you want to keep in mind for switch statements, break is a big deal. It's like the whole point of the case, actually. So I'll just put 5 in here and I'll stop at that, and then I will explain what's going on. So let's stop there. Okay, so now for switch statements, what you have is your expression, and then the case. For integers, it's case as the number. So if, let's say, you want to check for whether n is 100, 200, 300, then you would put like 100 in here. You would actually put the number 100 in here. So it's not like an if statement where you have a condition. Like here you have a condition. You have an actual number inside of case. But it has the same idea, which is basically that you start off with this expression here, and then saying if n is not equal to 3, or if n is equal to 3, do this. If n is equal to 4, do this. If n is equal to 5, do this. And then if n is equal to none of those, you go to the default, which is just going to be printing n. No, I want to print, let's just say a default number of 1. So let me run this code actually, and I'll show you with the actual like output of it. And so let's say I put 3 at first. It's gonna give me 3, and then I put 4. It's gonna be 4, and then I put 5. It's gonna give me 5. But then if I put 6, it's gonna give me 1, because there's no case for 6. So there's no thing saying if n is equal to 6, then do this. There's just default. Default is basically if none of these work, then you go here. And this is basically the else of an if-else statement, if you think of it that way. Now, that's the basic idea of switch case statements, but something very important in these is the break, and I'll show you why it's important, because you could change your output a lot. So if I enter 5, it's just going to give me 5. But if I enter 3, it's going to be 3 and then 3 again. And the reason it's doing that twice, so let me just not hurt everybody's eyes and put on different lights. Just give me a second. Alright, let me rerun that. Alright, so if I put 3 in here, I get 3 twice. I get it again for some reason. Okay, whatever. So I get 3 twice here because I remove the break. And removing a break in these case statements basically does this. It says if the case is equal to this, then do this one. But then it's not checking for this case. It's not going to say if the case is equal to 4. It's not like an if or an else if. It just automatically defaults to the next thing. So it's going to ignore this whole thing because you remove the break. But then if you do put the break, it's going to give you it's going to basically be an if else if kind of statement where it does it only once. So that's something to keep in mind. Break is probably the biggest part of it, in my opinion. If they test anything on switch statements, either going to be break, it's going to be the cases, or it's going to be like the expression itself. So that's pretty much what I can give for switch case statements, I guess. It's not much, like, it's not like crazy complicated. It's just a lot of it is pretty much just logic and understanding what happens code by code, and yeah, or line by line, code by code. what happens line by line. And yeah, that's pretty much it. I would say this part messed up the recording, so I'm gonna have to re-record all of this if like someone's in here and they missed it. So I'll post that later. But that was pretty much it for nested loops, file IO functions, switch case, and if I missed anything else, let me know. But I think I got everything. So yeah, if you guys have any questions, let me know. But that's pretty much it for the whole thing.
Yo, I got a question.
Yeah, go ahead.
Couldn't you pretty much write any switch statement as if else?
You could, but there's some things that you want in a switch statement specifically. Like these cases, if you were to put in if else, you would have to do it like this. If, and then this is equal to whatever, and then you would have your like expression here, and then you would have else if, and you would have your expression here, and then if you get what I'm saying, like you would have like so many else ifs, you just be copy pasting them. Like it's easier just to put a bunch of cases, because if you have a lot of cases, like if you want to like check 3, 4, 5, 6, 7, 8, 9, you don't want to put a bunch of else if, because you're gonna have to be putting like these things here, and if you're gonna put stuff inside of the if statements, it creates an even bigger problem. So generally, yeah, it's not like preferred, I would say, from my experience, that you use switch, but sometimes you use it and sometimes you don't. Like for example, in an if else statement or an if else if, you cannot just remove a break and then say, okay, that's end of the day, and then you move to the next one. No, you would have to actually make multiple if statements. So you would have this, you would have another if statement, and then you would have to make sure all these if statements don't collide with each other, or else you will get like multiple things repeating. But here, all you're gonna do is remove a break, and then it goes to the next one. So that hopefully answers that. Like it's not like that helpful, I would say, but in some cases, I guess you could use it. So yeah, hopefully that answers that question.
For the switch statements, are we able to use letters as well?
Yeah, so that's something I didn't go over, but I said, I think at the beginning, where you could just do like A, and then, or you know what, I'll just cover that real quick if you want to stay for this. So if I change this to char C, and then I do char, oh, I should actually move this to the top. And then please enter a char, and then C in here, and that should be right, I think. Yeah, okay, so I can run that and I can show you for characters specifically. So if I put A in here, oh, it's gonna give me 1. Why is it giving me 1?
Oh, you have the scanf as %D.
Yeah, I have it, yeah, and I didn't change all of these, so let me change all of these as well. So this is the only annoying part about switch statements, I would say, because you have to change like everything if you change to a different type. But I guess that kind of applies to everything. But yeah, let me rerun that. Alright, so still giving me 1. Nice.
At the very top, there's a %D in the scanf.
Yeah, thank you.
Yeah.
Small errors. Alright, there we go. So same idea. If you do B, gives you B. If you do C, gives you C. And then if you do D, it's gonna give you 1. So yeah, so you could use it with characters. You could even use it with strings, which we haven't really learned yet, but you could use it with strings. It still applies the same idea though. Like if you could use this in an if else if chain, but it's just a little bit more helpful if you're like checking for specific things. So yeah,
Okay. Thank you.
no problem. But yeah, if anyone else has questions, I'm just gonna stay around because I don't sleep until like 3 a.m. So. Yeah, that's pretty much the end of it. If you guys missed the first part, I'll probably post a recording in tutor announcements later. I have to redo that, but so maybe tonight or tomorrow morning. But yeah, that's pretty much it. I'm gonna just stop recording